Cool. So welcome back. Welcome to our JavaScript Meetup 51. So we have already completed last 50 events and old events. You can go to our YouTube channel and you can see the talk details over there. The recordings are available. So this talk is on Gitting. So Gitting, to the heart of it, I just love the topic name, and it will be presented by Rahul Kashyap, who is a senior engineer in JFrog. So over to Rahul, so you can brief about yourself and then jump to your slides.
Thanks, Patro, and thanks, Damini, for the introduction as well. So, as you mentioned, the topic name is catchy. I hope the content will also be something that people will remember. So, good morning, everyone. My name is Rahul Kashyap, and I'm a senior software engineer at JFrog. So basically, I try to cover this aspect in my slide as well, but just a brief intro from my side would be simple, ambivert guy, loves to code, and been with technology, I think, for 7+ years. Was there in the freelancing career, then moved to the corporate world after the graduation and so on. So yeah, looking forward to spread the knowledge, and I hope you like the session. With that, I'll just share my screen. And let me see if you guys, oops, not this.
So I can see it. Others can thumbs up if they are able to see it.
All right. So I hope everybody can see it now because I'm not able to see air meet. I'm just able to see my.
Yeah, a lot of thumbs up, Rahul. So yeah.
All right. Cool. So yeah, welcome to the session. The session is all about how we can efficiently make use of Git, and what is it to use the Git activities from the CLI instead of going to use a GUI tool. So again, myself, Rahul Kashyap, I'm a senior software engineer at JFrog. My area of interest lies in distributed system and also the cloud native architecture. So if any talk happens there, I tend to be interested there. Right? Personally, I like to code in TypeScript and Go, but yeah, I am open to explore each and every other option, given all the trade-offs on the table. Then, do I have personal life? Yes. I like to play cricket, foosball, and when given time, I watch some sci-fi stuff. So that's brief about me. Since this session is kind of coming from JFrog, we also have a very exciting raffle. So basically, at the whenever you register to this raffle, which is optional totally, there'll be some lucky winners announced, and they'll be getting the school T-shirt from JFrog. So this link will be there at the end of the slide as well, or you can scan the QR code. That's up to you. So moving forward, this is the whole packed agenda for us. So I'll start with the introduction of what is Git, and then maybe how to clarify what is a GitHub or BitBucket. I have talked to people and they have some confusion around it. Then the main point why people, or rather the developers, are hesitant to use the Git CLI, or they'll just use the GitHub UI or maybe the other UI tools which are available in the market. Then we'll start with brushing up some basics, like what is a branch, what does a Git repo structure look like, and so on. Then the motivation would be to go with the day-to-day activities which help you, like what is the rebase, merge, how do you cherry pick, how do you rewrite the history, and so on. Then we'll also talk about what are the caveats using the public histories or changing the public histories and so on. And at the end, I'll be happy to take any questions. All right. So to start off, very interesting question. What is Git? So this is very a bookish explanation of what Git is. But just to explain it in casual way would be, let's say you are working in a collaborative environment where you want to share your changes with the rest of the world or rest of your team members, right? And you want them to make changes as well that you absorb. So you want to have a centralized system in which you put your code base, and over the time you can verify what the changes were last time and what are the changes now. So it also can keep track of your changes that you have been doing. So Git is a system for you which implements a version control, and by version control we mean that it can keep track of the changes being done on a file or a directory over the time. So yeah, that's Git for you. And then when I talk to people, they say, hey, I know the Git, I know what Git is, but what is the difference between GitHub, BitBucket, GitLab, or Git then? So basically, Git is a system which anybody can implement and bring some functionalities on top of it. Just to name a few: GitHub, BitBucket, GitLab. They are the people who devised their user interface on top of Git. They provided very nice features like pull requests, issues, and so on. So when you go to GitHub, you create your account there and you create a repository. Underlying system which that repository is using Git is Git, but GitHub is giving you that nice UI to do a lot of other things. Pull request is something which is not part of the Git, but it is part of the system that you're using. So GitHub allows you to store your files on their servers. So they become the hosting servers which implement Git. They offer you the nice UIs to manage things. In short. But then, yeah, this is the main question for this topic. When I talk to people around this, they say, no, I'm afraid to do changes with Git CLI. I don't know what mess I can create, or maybe they have seen some obnoxious side of wrongly making use of Git CLI. So that's my motivation to have this topic around, spreading the knowledge, how you can make use of Git CLI without being afraid of it. And the idea is very simple. You need to learn the concepts. You don't need to by heart the commands, Okay, I know every time I go to my terminal, I need to do git pull or git fetch. That's it. But what is happening behind the scenes, you need to know about it. That's when you get the confidence of using something, right? So you need to know the concepts, or rather you need to know what is happening so that you can easily answer how it is happening. With that, let's come to the basics again for a quick few minutes. So basically, when we talk about Git setup, Git repository anywhere, we talk about two things. We talk about remote and we talk about the local machine. So in this case, I have, I have named that machine as dev. So what happens is remote is the guy which centralizedly store your changes, and local machine, which is a dev machine here, stores the machine, store the changes which are very temporary for your location, which are not shared by the remote or anybody in the world. And the idea is you do the changes and then you share it with the rest of the world. So the changes should go from here to here and vice versa. So when you set up any Git repository, what exactly happens is you have the repository on the remote, but the variant of that repository is structured into different parts, which are stored in your local machine. So first of all is called working directory. Then you have staging area, and then you have the local repository. So all of these boxes have their own semantics associated to them, which we'll see in the next slides. So to start off any project with Git, what you do, either you create the workspace on your own, and then you initialize the Git repository there, and then you push it to the remote, or the main or the most common scenario is the repository already exists on the remote side. Now what you do is you clone it, right? So let's go with the other way around. When the remote repository is there, now you want to clone it to your local machine. What happens? That you use git clone, the URL of it, and internally what Git does is it clones the contents of the remote repository into two places, which is one goes to your working directory, another goes into the local repository box. And how this bifurcation looks like, we'll see in the next slides. So just to mention, git clone, when you do it behind the scene, these many things are happening. And what is the motivation behind cloning a repository? Maybe you want to try something, or you want to share some of the changes that you are interested to do, and you want to share it to the community, right? So let's consider an example where the remote repository that you just cloned had a file called alice.txt, right? When you cloned it, you see alice.txt exists in working directory as well as in the local repository. Now, the change that you want to make is you want to add a file called bob.txt, right? That's why you see the plus sign here. Now, ultimately, when you want bob.txt to be available in the remote, it's a multi-phase or multi-step process. So it needs to move from one phase to another to another. What we do is, first of all, we add the file to the staging area. So this is the promotion of your changes from the working directory to something called a staging area. A staging area is where all the changes are being tracked by Git. So when you have a file or any change which is happening in the working directory and Git doesn't know about that change yet, it's not going to track that change. So if you want to notify the Git, hey, please track the changes happening in this file as well, you need to add it to the staging area. The way you do it is git add the file name or the directory name or whatever. You can use the wildcard as well. So this is what we mean when we add something to the staging area, and this is how the Git would be able to track it then. Then what we do is commit our change. So when you do git commit -m and provide a nice commit message, what it does is it moves the bob.txt from staging area to local repository. So now you see we are on the next step where we have just fired a command, and this is the side effect of that command. It moves the changes happened on the staging area to the local repository. So still the changes are on your local machine, right? They are still not yet shared to the remote one. So there's a last step that you need to do it, which is git push. That's it. So all the changes that you proposed from the beginning are shared with the remote repository as well. So everybody can see bob.txt now. You see, we did a multi-step process, and then ultimately we have the changes shared with every other people. So when the dust is settled, this is how it's going to look like. So congratulations, when you did this, you shared your changes, or you pushed your changes to a branch, right? You just pushed to a remote branch, which we might be interested to know about. So when we say branch, right, what does it mean? Basically, you just made a commit. So in Git, the branch is nothing but it's like a pointer to series of commits. So a commit in the Git system, it represents changes, right? And the way you remember those changes is by some a string which is containing alphabets and numbers. So let's say you made commit, another commit, another commit, and then another commit, and then you are at a point where you want to see that, hey, whenever I open my Git system, I need to know the current situation or current location where my changes are, or what is my top changes being done. So that's where the concept of branches come. So you made this commit as first 25E143D, and then other commits. The last commit that you performed, consider that was CEB545. And there you see there's a pointer called master, which is pointing to this commit. There is another pointer which is branch foo, pointing to this commit, which resembles that you have two branches at the same point of time, or they are pointing to the same commit. They are par with each other. Then we also have another pointer called head, which we can see later, which how this pointer can help us. Well, yeah, you have branches, but what is the benefit of having different branches? So ultimately, when you use Git, you want to collaborate with each other, right? You want to work in isolation somehow or in parallel, and then ultimately you want to merge the changes into one repository so that you are done with the big task, which was maybe divided into smaller tasks. So the merge resembles the merging of those changes together, and the way we do it in general is we create different branches, we perform some changes there, and then we take those changes back again into the, let's say, the base branch, which generally used to be called as master, but now GitHub is changing it to main. So let's stick with master for time being, and and consider this example where you have a branch called branch foo. You wanted to make a change, and again you wanted to bring this change to master branch, which is this. So all this boxes and the connections resembles a tree. Trust me, it looks like a tree, which in Git system, but here maybe not. It doesn't look like a tree, or rather, it's a graph. But consider this as tree, in which the master branch was pointing to a commit, and you went ahead and created a branch on top of master. So it started with this commit, then you pushed another commit to that branch called 273.866, and that's where your pointer is pointing to. Now when you say, hey, I'm done with my branch, you can go ahead and merge this branch to the master. This is what your expectation is. You want to have this commit available inside the chain where master is pointing. So I think that should give you the answer how it's gonna look like when you merge. So when we merge changes, there are two situations in which you can end up in. So first situation is very simple use case, like the last one. You see, this situation is like, okay, you want to merge this change into master. What you're gonna do is you're gonna just move the pointer of master branch to this commit. That means you have just merged the change. This kind of change, which is very simple and Git can do it automatically for you, is called fast forward merge. And the way you do it is you just say git merge the master branch. I want to merge my changes to master branch. That's it. So this is how Git is gonna do it. Master pointer would be moving to the commit, which is from branch foo. The other complex scenario, which is very trivial to happen in day-to-day basis, is where the changes are not that simple to be merged. For example, master branch was here, a master pointer was here, and you branched off and created a branch called branch foo, right? And then you created a commit in that branch, that is this. But when you were doing that changes in isolation, master branch, or there was another commit into master branch, which is 7503804. So naturally, when master branch was pointing to this commit and it got another commit, it is pointing to this one, right? Which is very natural. Now your branch foo, which was pointing to this commit earlier when it started off, doesn't know about this commit at all. And this situation is called as diverged branches. So you were working on a branch which is now diverged. It doesn't know what is the correct position of the master branch or master pointer is. To merge these scenarios, it's not that simple. And that's where the concept of merge commit comes into picture. So if you were to go ahead and merge these changes, this is how it's gonna look like. Git is gonna create a new commit, which is known as merge commit, and it's gonna point the master branch to it. But you see, the children of this commit is the commit that master branch is pointing to, and the commit which the branch foo created. So the complexity starts here, where this commit, which is merge commit C3FD56, is now pointing to two children commits. And consequently, the commit CEB545 is now having two parents. Again, this looks very simple to see in this diagram, but in real life, it can become very huge. And nobody likes it personally. Personally, I have seen nobody likes this approach where you have a lot of parents and a lot of children. So then what do you do in that case? If you want to have, let's say, a linear, clean history of, one commit is only having one children or one child and only one parent, you have something called as rebase. What rebase does, you specify that, hey, rebase my changes on top of master branch. So consider this scenario where branch foo had one commit, right? 273.866. So you are in branch foo and you're saying that, hey, you rebase my changes on master branch. What it means is you take changes until master pointer, which is 7503804, and then you apply the commits that you have in your branch one by one. And that's where the pointer head comes into picture. The head pointer can be available for any local branch that you have. It can be in your branch foo, it can be in master, anywhere. So head pointer moves commit by commit, and then it applies the changes that you have. So after you do the rebase, this is how your commit history is going to look like. You have the master branch changes still 7503804, and you have rebased your changes or branch foo on top of it. That's how your linear commit history looks like. So that's the difference between rebase and master, which is very trivial to get ignored. To get ignored, and it's very important to know when to use what. But a guideline or maybe a best practice, always prefer using rebase over merge. All right, when you do rebase like this and you try to push your changes, they are gonna reject it. They are gonna get rejected like this. And what exactly happens is, maybe you don't know, you do like you go to internet and search for, hey, something is happening to me, I don't know what is happening. So Git is also giving you a hint. It's saying that, the tree that you have in your local doesn't match the tree on the remote system. What you need to do, either you take the remote system tree and merge it into your local tree and then push, or you can do something else called force push. So when you do force push, what exactly happens is, whatever tree that you have in your local will be gonna be the tree in the remote system. So it's gonna replace each and everything that you have on your local system to the remote system. And it sounds dangerous as well. It is, right? When all the commit history that you have in your local system, it's gonna be the commit history on the remote system as well. So you have to do it very carefully, and you need to know exactly what you're doing when you do it. So force push, when your local tree is changed and you want the remote tree also be changed according to what you have, you are confident enough that this is the tree I want to have in my remote system, you need to do a force push. All right. So coming back to the old diagram where we saw the local repository had the changes, right? So it doesn't just have the changes, it also have the different other components into that architecture. So what exactly happens in repositories on the remote system is we have branches, right? And then we also have branches in the local repository. How they are being tracked or how they are related is with this diagram you can explain. So when you clone a repository, their branches on the remote are cloned or copied to the local repositories as well. But whenever you make changes on remote repository which are not known yet to your local system, they are not going to get reflected. So how the relation looks like is, let's say the master branch was there in the remote system. When you cloned it, it is going to create two entries. One would be in local branches and another is remotes. So remote is the reference of your remote system. You can have multiple remotes representing different remote systems, and you can have multiple branches representing the local branches of your system. So master branch on your local is referenced by origin/master, which is pointing to the master branch of your remote system. As simple as that. Branch foo similarly. So let's say the branch bar was created on remote system and you don't know about it naturally. So you need to know about this. How do you do it? You do git fetch, right? And people might ask you to, hey, do the git fetch and then you will know the changes. But what exactly happens is this. When you do git fetch, only one thing happens, which is Git is gonna update the remote section of it. It says that, hey, there is a branch called branch bar on your origin remote origin. I'm gonna just keep an entry here. But still, if you try to check out the branch called branch bar, you won't be able to because it does not exist in your branch section yet. Rather, what you need to do is do git pull. So when you do git pull, it's gonna do what git fetch does, but it also gonna update your branches section. So when you do git pull, then it's gonna create the branches bar in your local branches section as well, and you can easily check out this and make the changes, or maybe visit that branch for tracking the changes. So when you do git pull, we know it's gonna fetch the changes, but it also takes the changes from remote repository and tries to merge with your local changes, right? And by default, it's gonna use git merge strategy. And we know when we use git merge, what happens. If you have diverged branches, it's gonna create the merge commit, and then you'll have that tree, non-linear trees tree. Rather, you can pass git pull ---- rebase flag, which will run git fetch and git rebase in the background instead of git merge. So if you know the benefits of rebase and you want to have those benefits intact with your pull process, you can pass ---- rebase as the flag. Then we have something called a stash, which is very helpful. So a stash is a stack data structure. Whenever you are in middle of some changes and you want to park those changes in for temporary purposes, you can make use of stash. So each and every change that you do, it's gonna go on top of the stack. To save anything in this stash, you can use save and provide a nice description so that you can remember what the change is all about. To list all the stack changes, you can just say git stash list. When you see a stack, it also gives you the index number for each and every item of the stack. You can just say, hey, git stash apply that index number. So when you do git stash apply, the changes are gonna be applied to your local working directory, but the changes are still gonna be there in the stack. If you don't want the changes to be part of your stack anymore, you can do git stash pop. But git stash pop will always pop from the top of the stack. So always the 0th element will come to your working directory and it won't be part of your stack anymore. Then another interesting topic, which is very helpful, is called cherry picking. So very trivial scenario where people are working in parallel, and let's say somebody who was working on a branch called branch bar identified, hey, there is a bug which I can fix in my branch. And the person who was working on branch who realized that, hey, I also need that branch bug fix. How can I share, or how can you share the bug fix with me? First, a very simple thing is you copy paste each and every change that the guy on the branch bar has done to your branch, which is not a good idea. The changes could be huge. So what this guy can do is, this guy can say, hey, you know what? I'm creating a commit, which you can also take a reference to. So let's say that the bug fix commit is A216EE0, which branch foo is also interested in to have the changes off. You just run a command called git cherry pick the commit number. Ultimately, this is gonna happen. This commit is gonna be referenced to the branch in branch foo with another commit number, but the branch foo will have the changes whatever this commit has now. Very important to in a trivial working environment and very useful. All right, then one of the most interesting feature of Git in terms of writing history or rewriting history rather. And why do we need this? I think most of us have been in this situation, which is you wanted to change some contents to the file, then you forgot some of the changes, or then after some time you realize, oh, I could have also done this. That means you want to change something in the past. Or another common thing is you didn't write a good commit message, and in the code review, maybe you got this, hey, please correct your commit message. Then how do you do it? Situation where you are using multiple Git users and you pushed your changes with one user in the memory, which resembles another user altogether when it is shown in the UI. Or what if you didn't want a commit at all? Or what if you want to reorder the commits? So these are very few scenarios in which you would want to rewrite the history, but there could be hundreds of them, depending on how do you want to change something which happened in the past. So very fundamental thing would be to change the last commit. So you just pushed a change and then you realize that, hey, I missed something. What you can do is you just can say git commit hyphen hyphen amend, and your head pointer is gonna move from your current situation to the last commit, and you can do any change that you wanted to do. So you can write a good commit message this time, or rather, if you want to keep the same commit message as the last one, you can provide a flag called hyphen hyphen no edit. You can add a new file to the same commit, or you can delete a file from the commit. You can also specify a new author to that commit, or rather, interestingly, you can specify the date of the commit. So you want to change the date and time of the commit, you can specify it. So changing the last commit is very easy. You just say git commit hyphen hyphen amend, and changes will be reflected in the last commit itself. Again, when you do commit amend, it's going to change the tree on your local system, and you would need the force push to push those changes into the remote. But what is more common is you need to do the time travel, right? You need to go into the time and then do a lot of changes. Again, if you know what needs to be done, then it's simple. Otherwise, if you just maybe mug up the process, hey, last time I did that way, so I'll just follow the same thing. It's gonna be very convoluted convoluted process for you. So what we need is called interactive rebase. Interactive rebase would be applying changes one by one, commit by commit. Interactive means it's gonna give you the list of operations that you can perform. So the idea is simple. We want to go back in time and apply the changes and come back to the current position. The way you can do it is you can specify -i flag when you're doing with respect to a branch. Or you can say, my head pointer is pointing to this commit. I want to go back 4 commits behind the time and then make some changes. Or you can also specify some commit hash saying that I want to go back in time until this commit. As soon as you fire any of these commands, this is going to be the command prompt which is presented to you by Git. It can come to your favorite text editor or whatever the editor that you have configured. By default, it comes to the command prompt as a Linux or Unix kind of system in VI editor. So Git presents you with this. It presents you that how many commits that you have with their commit message and hash, and also an option called, or the first column says the operation that you want to do. By default, everything is pick. And if you see these commands where everything is explained quite well, when you say pick, it's going to use that commit like that. Nothing is going to get changed. So if you replace...
So, hey Rahul, sorry to interrupt. So, do you like to take questions in between or at the end? Whatever way you prefer.
I think I'll go with at the end.
Okay, cool.
All right. So, yeah, if you replace this pick with reword, what it's going to do is it's going to use the commit, but it's going to ask you for the nice commit message after it. So use reword if you want to change the commit message. Then other important command is edit. So as soon as you mention anything, any row as edit, Git is going to apply each and every change, and as soon as it finds edit, it's going to stop there. So it's going to be the same situation where as if this was the last commit that you did. And changing the last commit is very simple. We have already seen. Once you're done with your changes, you need to just say git commit hyphen amend. That's it. As soon as you are done with that, you just need to continue your rebase process. Squash, one of my favorite. When you have multiple commits and then you want to combine all those commits into one, use squash. Fixup is like squash, but fixup is gonna give you the flexibility of writing a new commit message for the combined commits. In a squash, if you have 4 commits, the final commit message will be all the commit messages separated by /n. Apart from these, another one which is important to know is drop. because you have this commit history and now you don't want a commit. What you're gonna do is you can just specify drop. So Git is gonna drop that commit at all. It won't be seen in your history at all. So if you just look at this use case, we have certain operation that we did. Now we want to rectify our mistakes. For example, we added ls.txt. Now we added some text inside that file, but we forgot to add some of the text. So we might want to rectify this and make one commit out of it, having just text inside ls.txt. Then we added one file called bob.txt, but we messed up in the commit message. So we might want to rectify that. Then something was not happening. Let's say we made a test commit to see if push is happening. Now we have this dangling commit in our history, which just doesn't do anything. We also have a commit which is having the wrong username. So we might want to correct that. Committed by mistake, we might want to drop this. So if you're with me, ultimately you would want to have these operations being done. Pick would mean I want to have this commit. Pick, I want to have this. Fix up would mean that I want to squash this change with until you find a pick. Yeah, so that's one of the caveat. If you use squash or fix up at any point of time, it's gonna squash up till a point where it finds a commit with pick. So when we did fix up, it tried to find what is the top commit which is having pick, is just the immediate one. So it's gonna merge this commit into this, having, or it will be asking you to provide the nice commit message after it. Then reword, again, it will say that, hey, it will ask you for the nice commit message. You want to change the commit message. You want to drop this commit. It was a test commit. Again, drop the commit. And you want to stop here for changing the author. So once everything is done, this is how the final history would look like. You have ls.txt, you have text inside that file, you have bob.txt, updated bob.txt, added a file, or commit with, rather, it would be right username this time. So you see, from this commit history, which is very messed up, you came to a final commit history which is lean and very simple to understand. That's very important to know, because this could be a strategy in your organization to perform all the commit history as linear as possible. So you can change the history, we know, but you have to be very careful while dealing with public history. Public history means you have a repository which is publicly available, and when you change history, it's going to affect all the consumers of that repository, right? Because they are not going to know, or all the changes that they have is going to be overwritten as soon as they take a pull. So you should avoid it at all if you're dealing with public repositories. If at all required, you should do force push, but with this option called force with lease. What's going to do, let's say while you were changing the history, somebody pushed some commit into the remote repository. Now you're not aware of that at all. So when you try to do force push with force with lease, it's going to check, hey, what you're going to push, does it resemble the same state where you started at? If not, then it's going to fail that push. So having those race conditions in between, force with lease flag is going to help you. So avoid, long story short, avoid public history changes. If at all required, use force with lease, or even make a habit of using force with lease every time instead of just force. Then writing the history is fine, but you can also read the history. So there is a tool in Git called reflog, which is like a ledger of each and every change that you do. It's gonna be present in the let's say a journal. You can always open that journal and see what all the changes were done. For example, you started a rebase process and you completed the rebase process, and now you feel like, no, this rebase doesn't look good. I want to go back in time. So the rebase is not a commit, right? So you can't just drop it and so on. What you want to do is you want to reset or you want to move your head pointer to something else in the time. So Git reflog can give you each and every instance where you started the rebase process, and you can just reset your pointer to that point. So reflog is like a ledger. Each and every transaction is being recorded there. You can refer any of those and move your cursor there. It is very important as well in terms of you want to have relative changes. For example, how many changes were done since yesterday. So those kind of things can be done in Reflog. I think with that, this is all from my side. And again, can make use of this link to enter into raffle and get a chance to win the t-shirt. All right, would be happy to take the questions. I hope there are
Yeah,
questions.
Rahul, if you want to paste that link to the chat also for the raffle, I think that will help.
Yeah, that's a good idea.
Yeah, so guys,
Hey,
it's a question time. So if you guys have any questions, you can raise your hand or type in your question in the questions tab. So I see one question,
so
Rahul.
I
Yeah,
see already a question between amend and revert. Yeah, that's interesting. So amend would be an operation that you do on a commit saying, hey, I want to change the last commit at all. So you provide hyphen hyphen amend, and all the changes that you want to do would be happening on the last commit. Revert, on the hand, is a commit altogether, a new commit altogether. So let's say you have done some changes, and now you want to revert those changes. So let's say you created a file, now you want to remove that file. What you're going to do is either you drop that commit at all, it won't be visible in your history. But if you do revert, it's going to have one commit which is adding that file, and then revert commit which is removing that file. So you'll have plus changes and minus changes. So revert, just to answer, revert is also a commit. If you do, it's gonna minus all the changes that you are interested in, but that commit will also be in your commit history. Very, very basic example is, let's say you pushed some sensitive information in your repository. Now you realize that, hey, this sensitive information shouldn't be part of this repository, so I should revert that commit. But the revert commit is also a commit. It's gonna be available in your history. Anybody can go to that commit and see that, okay, you removed this file, right? So they can still get the information out of it. What you're gonna do is you're gonna drop that commit at all. You're gonna maybe amend that commit and change your history and uh, and then push the new history altogether. So in that case, people will not know that there was a commit which introduced a sensitive file. So that's the difference between revert and changing the history at all. So which approach you go with? Is it related to any other question? Okay, it was by mistake. How to handle binary files or files with unknown extension file in Git? Well, for Git, any file is a file, right? Now, if you want to have any specific changes being tracked with the files itself, you might want to break the files into that kind of stuff. The general convention is if you are pushing any binary to the Git, you're doing something wrong. So the Git is not a system to upload your binaries to. You should use some binary artifactory kind of tools. Why Rebase is better over merge? Yeah, as I explained, merge is gonna give you non-linear history, right? You can have a commit which is pointing to multiple children, and one commit can having multiple parents. If you want to avoid that, you want to have very clean and lean commit history. Rebase is the guy that you're looking for. So general practice is always prefer Rebase over merge, because Rebase is gonna give you a commit, lean commit history, a linear commit history that you can always, comprehend by reading of it. That, okay, this change happened in this series of time. What would that mean? Scenarios where fetch is useful. Yeah, of course. So let's say you are working on a branch, and you got to know that somebody pushed some changes in another branch. You just want to rebase on top of that branch. You don't want to take any pull of those branch changes. So you can just say, hey, Git, fetch me all the remotes which are changed. It's going to fetch all the remotes branch. It's not going to create any local branch in your system. And you might want to rebase on top of your remote branch at all. That's it. So you can say git fetch one command which is which will fetch all the remotes to your local system, and then you can say git fetch origin slash, let's say, foo. So it's gonna rebase on top of what your branch foo is having the changes on your remote. So git fetch will be helpful when you just want to fetch all the remote changes, or you want to track all the remote branches in your local system. That's it. Um, my local Git repository often gets corrupted. Any best practice to follow so it doesn't get corrupted? Well, I think I don't get what do you mean by corrupted. So if you mean that something is messed up there, then first of all we'll need to identify how it got messed up, and the idea would not to do the same mistake again. How Git compresses the files, how its intelligent logic. Yeah, well, that's a altogether different topic. Git uses some binary trees to compute the hash, and the way it computes the hash is very intelligent. And by hash, it identifies what are the changes present in this commit. So that's altogether a different topic. What is merge with no FF? Yeah, this is like no fast forward merge. FF is fast forward. So you know that when the diverged branch happens, the case of diverged branch happens, you can't directly merge those changes. You need to have a merge commit in place. So that's where you can have that flag. In a company where we are TL, would you recommend rebase option to your juniors? Yeah, again, it's a best practice, but it doesn't mean that all the best practices in the world you should adopt and right away use them. You should see what is best for you. If your organization sees the benefits using rebase, go for it. If merge is suits better for your use cases, stick with merge. So the more important question would be how those things are different with each other. If we understand the difference, then we can be in the very good position to decide upon what to use when. So yeah, I would recommend both to my juniors, saying, hey, there is a merge and there is a rebase. Now you go ahead and try to find what could be the better thing. Usually the index gets corrupted. What is the reason for this usually? Well, index would mean that your staging area gets corrupted, and by corrupt, if I assume your changes which were not supposed to be there are there, that means you pulled some of the changes from remote, and those changes have messed up your local changes. So that process is also something that you should be very cautious about. When you pull some changes from your remote, it's gonna keep all the changes in your local and automatically merge whatsoever it can. If you think something is not right, you should revert those changes back to a point where you had your changes and try to do commit or cherry pick those commits one by one and see what is making wrong or what is causing the your index getting corrupted. So again, in short, if you think taking the pull is breaking your changes on your local, don't take a pull directly. What you do is take commits, cherry pick in your branch, and see if something's if everything is right or not. By commit, by each and every commit, you can realize that something is wrong, and that's where you can stop and then try to analyze what could be the reason of your index getting corrupted.
Cool. Rahul, sorry to interrupt you. I think we are a little out of time now. So what
Yeah,
you can
sure.
do, Rahul, you can stay online and you can see these questions and you can answer those on a chat. So
Sure.
that so guys, you can keep asking question to the Rahul. Rahul will be here for 30 minutes. Rahul, another 30 minutes. Will
Yeah.
be cool. So
Yeah.
another 30 minutes he will be here. So you guys can asking question to Rahul. You can directly chat with him also. So we'll be starting our second session in couple of minutes. So stay tuned. I'm just ending this session and we'll be jumping to another session. Thank you very much, Rahul. It was a really awesome session. So I also a lover of Git CLI. So rather than using any tool, I love to use Git CLI. So I loved your session.
Thank you.
Cool. Okay. So see you guys on our second session.